In this video, we will discuss infinite limits. And to do so, let's consider the motivation given by the graph below. And the question, what happens to the graph of this function f of x as x approaches minus 1? Well, as x approaches minus 1, it seems like the real question would be, what happens as you approach, say, minus 1 from the left or minus 1 from the right? It looks like as we approach minus 1 from the left, our function values are getting very, very large and negative. And when you approach minus 1 from the right, it looks like those function values are getting very, very large. So in this case, what we would do is say that that limit is plus or minus infinity. We say that the limit as x approaches c from the right of a function is infinity if the values of f of x become larger and larger without bound as x approaches c from the right. So looking at the motivating example, we would say the limit as x approaches minus 1 from the right of our function is infinity, and the limit as x approaches minus 1 from the left of our function is minus infinity. And if you have a one-sided limit that is plus or minus infinity, like we have in the example above, what this tells us is that in this case, the line x equals minus 1 is a vertical asymptote. An idea that will come up later this semester when we are using calculus to graph functions. So let's look at a few examples. We'd like to evaluate the limit as x approaches 1 from the right of the function 1 over x minus 1 quantity squared. Now, the function we are taking the limit of is a rational function, and because we're dividing it by this x minus 1 quantity squared, where there's nothing in the numerator we can use to cancel off those x minus 1s, we're going to have that x equals 1 is a horizontal asymptote. I'm going to write just HA for horizontal asymptote of our function. So that tells us that the limit is going to be plus or minus infinity. But the question really becomes, which one is it going to be? Positive infinity or minus infinity? In order to do so, we just need to determine what is the sign of our function just to the right of 1. So two ways to go about this. And the first way I think is the best approach is to just make a table of values. So much like we've seen earlier when working with inequalities, we need to think about where this function changes sign. It will change sign at a 0 of the numerator or a 0 of the denominator. And the only such 0 here would be the number 1. So that means everywhere to the right of 1, our function is going to be positive or negative. Everywhere to the left of 1, it's going to be positive or negative. We want to know what's happening to the right of 1, so you choose a sample point. So you think maybe something like 2. So if we plug x equals 2 in, we'll have 1 over 2 minus 1 quantity squared, which is simply just 1, but more importantly, it's positive. So our function is positive to the right of 1. So we know that the limit as we approach 1 from the right is plus or minus infinity, and the function is always positive to the right of 1. So that means the only possible value for our limit would be the positive infinity. So let's use this same approach to determine the limit as x approaches 2 from the right of the quantity given here. So because of the x minus 2 factor in the denominator, and the fact that it does not factor out of the top as well, so no simplifications are going to be available, that means x equals 2 is a horizontal asymptote. A vertical asymptote. And because it is a vertical asymptote, that means the limit is going to be plus or minus infinity. And in order order to determine whether it's plus or minus infinity, we need to know what is the sign of our function, just to the right of 2. So similar to our previous approach, the function that we have, x plus 1 over x minus 3 times x minus 2. We make a sign chart for the function. It can be equal to 0 when the top is 0, so minus 1, or when the bottom is 0, 2, and 3. So in between any of these values, the function is going to be entirely positive or entirely negative. And what we're really interested in then is what is happening between 2 and 3. And I think the simplest value we can pick in between might be, say, the number 5/2. So if x is equal to 2.5, and we plug that into our function, we'll have 2.5 plus 1 divided by 2.5 minus 3 times 2.5 minus 2. And all I need to know here is whether this expression is positive or negative. So what's in the top is positive, 2.5 minus 3 is negative, 2.5 minus 2 is positive. So a single minus sign means that this is going to be negative. So in between 2 and 3, our function is always negative. And if our function is always negative between 2 and 3, and we know the limit is going to be plus or minus infinity, that leaves us with the value of our limit being minus infinity. So let's evaluate the given one-sided limit. As x approaches 0 from the right, of absolute value of x over x. Now this example is a bit different than the previous two, in the sense that x equals 0 is not going to be a vertical asymptote of the function. The reason being is we have something to cancel it with in the numerator. So recall previously that we've seen that the absolute value of x is defined piecewise as being x when x is bigger than or equal to 0, which is what we are interested in, or minus x when x is negative. So since we are dealing with the x bigger than 0, we're approaching 0 from the right, we can replace the absolute value of x with just an x. So this will be the limit as x approaches 0 from the right of x over x. X over x is 1, so it's a limit as x approaches 0 from the right of 1, and the limit of a constant is that constant. So let's now evaluate the limit as x approaches 3 from the left of x squared over x minus 3. Very similar to our previous approach, we note that we have a rational function, that x minus 3 term is not going to cancel from the bottom, so we know that x equals 3 is a vertical asymptote, which tells us that the limit is plus or minus infinity. So the question is, as we approach 3 from the left, will it be plus infinity or minus infinity? So to see this, we make a sign chart. X squared over x minus 3. So the top is equal to 0 at 0. The bottom is equal to 0 only at x equals 3. We are interested in approaching 3 from the left, so we would like to know the sign of our function between 0 and 3. So a good sample point to pick would be 1. When x is equal to 1, our function is 1 squared over 1 minus 3. 1 squared is positive, 1 minus 3 is negative, so our expression is less than 0. So between 0 and 3, our function is negative. So as we approach 3 from the left-hand side, our function is always negative, and we know the limit is plus or minus infinity, which implies that it has to be minus infinity.